Alright guys, so tonight we're going to look at what acids are and how to distinguish acids from a list of compounds. And then once we are able to distinguish acids from a list of compounds, we can then learn the rules to name them and go about naming them. So the first thing is, an acid is a compound that gives off hydrogen ions when dissolved in water. And basically, if it's going to give off hydrogen ions when dissolved in water, hydrogen ions are positive, so they're cations. So the first thing we're going to look for is we're going to look for compounds which have hydrogen in them. And where they're going to have hydrogen in them is going to be in the cation position. So they're going to look like ionic compounds, but instead of having a metal in the cation position, they're going to have a hydrogen. And then they're going to be bound to some other nonmetal. Alright? It could be another nonmetal atom, or it could be a anion polyatomic ion. Alright, so it could be a polyatomic anion. And depending upon what the anion is, that's going to determine the name of the acid. So let's look back to our flowchart. Alright, at our flowchart, once we determine something's an acid versus a covalent compound versus a ionic compound, alright, we have another question to ask ourselves. So remember, the acid is going to look ionic, but the cation is going to be hydrogen. So we have to ask ourselves, does the acid contain oxygen? So basically, is it a hydrogen bound to a polyatomic ion, or is it a hydrogen bound to some other element? If it's bound to an element, then it's going to be a binary acid. And there's a separate set of rules for binary acids versus those acids where it's hydrogen bound to one of the polyatomic ions. So if it's a binary acid, we're going to start the word off with the word hydro. We're going to use the prefix hydro. Then whatever the anion is, we're going to name that anion. And then instead of having an "-ide" ending on the anion, we're going to add an "-ic" ending. And then we're going to follow up with the word acid to really distinguish the fact that we have an acid. So if I have H2S, I have a hydrogen cation bound to some other element. In this case, it's sulfur, which means this is a binary acid. So we're going to start the name off with hydro. We're going to name the anion. In this case, it's sulfur. And we're going to add an "-ic" ending. So we have hydrosulfuric. And then we're going to add the second word, which is just acid. Now, if the hydrogen is bound to one of the polyatomic ions, we have what's called an oxyacid. Please excuse my spelling error. We have an oxyacid. Alright? And all the oxyacids have the same ending. They all end in "-ate. Alright? So all of our polyatomics all end in "-ate. We have carbonate, sulfate, phosphate, chlorate. All we're going to do is we're going to change the "-ate" ending to an "-ic" ending. And then we're going to add the word acid. Notice, for oxyacids, we do not use the prefix hydro. So an oxyacid is something like H2SO4. We have hydrogen in the cation position bound to one of our polyatomic ions, in this case sulfate. To name this, we're going to name the polyatomic ion, which is sulfate, and we're just going to change the "-ate" ending to an "-ic" ending. So in this case, we have sulfuric acid. If you notice in the previous example, we had H2S, which was hydrosulfuric acid. The only difference between the two is the prefix hydro when we only have a binary acid. So when we write the formulas for these, we're always going to write hydrogen first. And then the name's going to tell you the anion. And lastly, we have to make the charges cancel out, just like we do with any ionic compound. So let's try to name the following. HF. We do not have oxygen in this, so this is a binary acid. So we need to use binary rules, which means we're going to use the prefix hydro. F is fluorine, so this is going to be, instead of fluorine, hydrofluoric acid. H3P. Once again, we have a binary acid. We're going to use the prefix hydro. We're going to name the anion, which is in this case phosphorus, but we want to replace the suffix on phosphorus with an ic ending. So we're going to have hydrophosphoric acid. H2SO4. This is the example we had previously. Sulfate has an oxygen in it. It's one of our polyatomic ions. This means it's a oxyacid. We're going to name this by just naming the polyatomic ion, which is sulfate, but we're going to change the suffix to an ic ending, and sulfuric acid. H2ClO3. This would have an oxygen in it. This is an oxyacid. It's chlorate. This would be chloric acid. HCN. Cn is a polyatomic ion, however, Cn does not have an oxygen in it. So we're going to use the nomenclature for a binary acid. So this would be hydrocyanic acid. H2CrO4, we have oxygen in it. It's an oxyacid. This would be chromic acid. Now, to go backwards, to write formulas for the following, all we're going to do is see that we have the word hydro here. So we know that it's just going to be hydrogen and one other element. And the other element is going to be iodine. So we know we have hydrogen and we have iodine. We need to make sure the charges balance out. Least common multiple of 1 and 1 is 1. We need 1 of each atom. So our formula is Hi. Acetic acid. Acetic acid has no prefix of hydro before it, so we know it's going to be one of our polyatomic ions. So we know that we're going to have hydrogen and our polyatomic acetate. And acetate is C2H3O2 with a -1 charge, +1, -1. They balance each other out. We need 1 of each. We have the formula for acetic acid. Carbonic acid. We don't have the prefix hydro, so we know we're looking at carbonate. We have hydrogen plus 1, carbonate, which is CO3 negative 2. Least common multiple of 1 and 2 is 2, which means we need 2 hydrogens and 1 carbonate, and we have the formula of carbonic acid. We can skip phosphorus acid. I want you to try at home hydrobromic acid, and we're going to work on the worksheets in school tomorrow. Okay, so what do you need to do to show that you've done this assignment? First off, I would like you to have the rules for naming a binary acid and the rules for naming an oxyacid in your notes. You should also have in your notes an example from each of the practice problems that we went over for naming as well as writing formulas for. And I will look for the completion of the acid hydrobromic in your notes as well. All right. We'll probably have the quiz on acids on Wednesday or Thursday of next week.